Okay, so welcome to another Salem Center event on energy and the climate. So great to see all of you here, and a lot of you are online as well as we start here. At the Salem Center, I don't know if you have the slide here with our tagline. We care about objective evaluation of policies and its impacts on human flourishing and progress. We strive to be honest and open about the trade-offs we face. Climate policies, perhaps, are the most consequential policies that are being discussed and implemented these days in all societies across the world. But believe it or not, at places like universities, in this university in particular, you wouldn't think that there's any trade-offs to be talked about. When it comes to the so-called climate crisis, universities act like partisan activists and betray the central core of their mission. But thankfully, with the support of private money, many of you sitting in the audience here today, and groups like the Salem Center and the Steamboat Institute, we're still able to convene in this campus built by fossil fuels, the name at the door is one of those, and listen to leading scholars debate and discuss the values of the ideas that will shape our future. Before I start, I want to make sure to thank, and in particular, Ted Williams, that's sitting over here. Ted, for organizing and helping with the fundraising for this and many other events on energy that we run here at the Salem Center, not only financially, but with his time as well, and we much appreciate that. You have a lot of our sponsors on that you see here on the slide today, but I want to name them all. So I want to thank Ameridev, Anthem Minerals, Atlas Sand, Brigham Exploration, Bob Brigham personally, Carly Gillespie and Ashton, I think, ES3 Minerals, Espuela, Hatch Minerals, Hilltop Resources, McCarran Partners, Moon Tower, Rockport Companies, Texas American Resources, Tower Rock, and VTX Energy Partners. So thank you all for your generous support. Haley, do you want to come up and introduce our panel? So this and the Steamboat Institute, and we'll go from there. Thank you and welcome again.
Well, good evening and welcome everyone. My name is Haley Supergan. I'm the Vice President of Development at the Steamboat Institute. It is a pleasure to join Carlos and the Macomb School of Business, the Salem Center, in welcoming you all here tonight for the latest installment of our Campus Liberty Tour. I would also like to welcome all our virtual audiences, including those hosting watch parties at the South Dakota School of Mines and Technology, University of Pennsylvania, Cornell University, and many other individuals watching across the country with us. Steamboat Institute launched the Campus Liberty Tour in 2018 with the goal of fighting back against the cancel culture that had taken hold on college campuses and society by encouraging free and robust debate. So that's what we're here tonight to see. As a nonprofit, nonpartisan organization, Steamboat Institute relies on the generous support of individuals and foundations to host programs such as tonight's debate. And I would especially like to thank all of the sponsors with the Macomb's School of Business Salem Center here tonight and the Adolph Coors Foundation for their support of the Campus Liberty Tour nationwide. Tonight's program will debate one of the biggest issues of our time, with the resolution being climate science compels us to make large and rapid reductions in greenhouse gas emissions. I encourage all of you to vote in the pre-debate poll, either with the link that you received via text just a couple minutes ago or using those cards that are scattered around the room. And for anyone watching virtually, they're able to vote as well. So we hope that all of you will share your views on this issue before we get into the debate. And then following the debate, we will vote again and see if anyone's opinions have changed based on the information they learned through our incredible debaters. And with that, let me welcome our debaters to the stage and we'll make some brief introductions. Arguing the affirmative, we have Daniel Schrag. Dr. Schrag is the Sturgis Hooper Professor of Geology and Professor of Environmental Science and Engineering at Harvard University. A graduate of Yale, he received his PhD in geology from the University of California, Berkeley. Dr. Schrag co-founded the Potential Energy Coalition, a nonprofit organization that harnesses the best minds from marketing and advertising to communicate the risks of climate change to Americans. He also served on President Obama's Council of Advisors for Science and Technology and is a member of the American Academy of Arts and Sciences and a fellow at the American Association for the Advancement of Science. Welcome, Dr. Daniel Schrag.
Thank you.
Arguing the negative on the resolution is Stephen E. Koonin. Dr. Koonin is a professor at New York University with appointments at the Stern School of Business, the Tardon School of Engineering, and the Department of Physics. A graduate of Caltech, he received his PhD in theoretical physics from MIT. His best-selling book, Unsettled: What Climate Science Tells Us, What It Doesn't, and Why It Matters, was published in 2021. Dr. Koonin served as Undersecretary for Science in the U.S. Department of Energy from 2009 to 2011. Before joining government, he spent 5 years as chief scientist for BP, and for almost 30 years, he was the professor of theoretical physics at the California Institute of Technology. Dr. Koonin is also a member of the National Academy of Sciences, American Academy of Arts and Sciences, the Jason Group, as well as a trustee of the Institute for Defense Analyses. Please welcome Dr. Stephen Koonin. And the moderator for tonight's debate is Tom Rogan. Tom Rogan is a foreign policy and national security writer for the Washington Examiner. Among others, he has previously written for the Washington Post, The Independent, The Atlantic, National Review, The Telegraph, and The Guardian. He was the inaugural recipient of Steamboat Institute's Tony Blankley Fellowship for Public Policy and American Exceptionalism in 2014. Welcome, Tom. And with that, the stage is yours.
Over to me. Ladies and gentlemen, welcome. Thank you very much for joining us this evening. And gentlemen, thank you very much for being part of this important discussion. Alongside you, you hopefully have a QR code, which you can use both to submit questions, which would be great, because then when we get to the sort of moderated element of the discussion, we can hopefully get your input into some of the themes and concerns that you might have. In addition, we want to start off the debate, if possible, with your vote on the motion, which is climate science compels us to make large and rapid reductions in greenhouse gas emissions. And so your options there, agree, disagree, or undecided. If you vote now, then we can, at the end of the debate, have another vote and see if opinions have changed. But enough from me. I think we can get underway. Dan, if you want to start us off with your opening statement.
There we are.
All right.
It's a good place to start. I'm a geologist. So humans are conducting the most extraordinary experiment on the planet Earth. Over the last century and a half, we have added greenhouse gases to the atmosphere, and the climate is changing. Temperatures have already warmed up over the last century by a little more than a degree, about 1.2 or 1.3 degrees Celsius. And we understand, actually, that this is due to a rise in carbon dioxide. This is the famous Keeling curve. Dave Keeling started measuring CO2 in 1958. It's now over 420 parts per million. When he started measuring it, it was 315. Now, to put this in context as a geologist, I'll do that for a second, but this is really an old problem. Over 100 years ago, over 120 years ago, this man, Svante Arrhenius, 1896, he published this paper on how carbon dioxide levels in the atmosphere affect the temperature of the ground. This is one of the founders of physical chemistry and the first Nobel Prize winner from Sweden, which is a big deal. He wrote in his popular book in 1908, this is the translated version, I think the original came out earlier, he said that basically if carbon dioxide levels doubled from burning coal, which was the dominant fossil fuel back then, that temperature would go up about 4 degrees Celsius. We think he was wrong. It's probably closer to 3 degrees Celsius, but still, from 1896, that's pretty good. So essentially, the physics of this has been worked out for a very long time. But of course, we've learned a lot more. As a geologist, I actually came to this problem really thinking about the history of climate. And so this just shows the history of carbon dioxide level in the atmosphere. You see fluctuations associated with the coming and going of the big ice ages over the last several million years. This is the last 800,000 years of carbon dioxide levels reconstructed from ice cores. And the last bit is the Keeling curve put on there. Just in the last 70 years, we've seen CO2 levels shoot up to levels we haven't seen for millions of years. And of course, millions and millions of years ago, 50 million years ago, when the Earth was much, much warmer than today, we also think carbon dioxide levels were much higher. So there's lots of geological evidence to support the idea that higher greenhouse gas levels will lead to much warmer temperatures. Now, is anything that we're seeing today natural? How do we know it's not just some natural cycle? Well, as I said, we know what the natural cycle is, and this is nothing natural. But this is a guy named Lonnie Thompson from Ohio State University. He studies tropical ice sheets all over the world at very high altitudes. And these ice sheets around the equator are actually like canaries in the coal mine. They're very stable because temperatures at the equator don't change very much, especially at high altitude. And what Lonnie has shown is that these ice sheets are melting now all over the world for the first time in thousands and thousands of years. And so this really brings it home that what we're seeing is not any kind of natural cycle. We're seeing something extraordinary. And the timescales of this system are just getting underway. So what does it mean for the future? Well, you can run climate models, and climate models have their problems, but they're the best, represent the best knowledge we have today of the physics and chemistry of the Earth system. These are projections for different scenarios because, of course, the future is partly up to us. How much greenhouse gas will we continue to emit? And what these show are essentially our very low, low, medium, high, and very high scenarios of emissions. And the Earth is going to get warmer by 1, 2, 3, 4, maybe even 5 degrees Celsius. Just to put that in perspective, 5 degrees Celsius is the difference between the last ice age 20,000 years ago and today. So 5 degrees Celsius globally is a really big deal. But most of us don't experience global temperature. So what do we experience? Well, one thing that's extraordinary is what's happening in Greenland. We're seeing the surface of Greenland melting now every summer. This didn't happen in the past. This is a figure just showing mass loss on Greenland from the 1970s through today. And you just see this extraordinary decline and this is due to summer melting. Today, every summer, the surface of Greenland is melting almost all the way to the summit. That never happened before. In Antarctica, it's actually more troubling because what's happening to the Antarctic ice sheet is not melting. It's still so cold that it's not going to melt. It's the heat in the ocean. 90% of the greenhouse gas effect on the Earth's surface temperature is actually, the heat uptake is actually going into the ocean. And so the ocean is warming. That's very hard to reverse. Again, the timescales of this are incredibly long, centuries to millennia. So we're doing an experiment. It's not so easy to reverse. And the water is getting under the ice sheet and potentially destabilizing certain parts of Antarctica that, again, will drive big sea level rise. But let's talk about how climate affects people because, global temperature is not what we experience. This is a picture of China in Zhengzhou, a city most of you probably have never heard of. 2 summers ago, they had an incredible rainstorm. It rained 8 inches in 1 hour. Now, what's interesting about this is scientists, colleagues of mine, meteorologists, climate scientists, predicted that climate change should lead to more intense rainfalls. And that's what we've seen all over the world. In Zhengzhou, they got 8 inches in 1 hour. Unbelievable. People drowned in the subways as the subway tunnels filled up with water. It was the most horrifying situation. But I don't need to tell you about the extreme rainfall. Just not that far away from here, a few years ago, Houston had Hurricane Harvey, dumped 60 inches of rain in a few days. 60 inches. That's biblical. And this is pictures from Houston. Hard to imagine. And parts of Houston are still recovering from this disaster. And then there's what happened in Pakistan 2 summers ago, not in 2022. The Singh Valley in southern Pakistan was flooded and 33 million people were displaced. Now, the monsoon is occasionally extreme like this, but a variety of studies have shown that the overall warming temperatures made it much more likely that this sort of a damage would occur. And this brings up the issue of equity. We have to talk about ultimately who caused this problem and who's suffering from it. This is a figure showing the cumulative emissions of CO2. And for those unfamiliar with this, it's the cumulative emissions that the Earth system really cares about, not the emissions in any one year, it's the cumulative emissions. And you see the US is about 25%, Europe's about a little less, China's only 12%. It's actually closer to 15 now because it's growing so fast. But Pakistan is it's roughly 0.25%. That is 100 times smaller than the US. And the op-eds in Islamabad were saying they did this to us. This is incredible suffering, and I'm really worried about especially South Asia. Let's talk about heat. Again, people in Texas understand heat. Summers have been getting more and more unbearable here, but in South Asia, it's a different scale. This is from 2019, a huge heat wave of 123 degrees, 50 degrees Celsius. 2021, similar. And then in 2022, 30 days of 50-degree temperatures, 123 Fahrenheit. Unbelievable. This is getting close to the point where literally people can't survive. What happens as the Earth continues to warm? There are 2 billion people living in South Asia. How do we think about how they will manage this? So the answer is we have a choice. What will actually happen in the future? Let's look at energy systems and what's actually causing this problem. This is the history of energy from 1800 through 2008, and you see the incredible rise of fossil fuels. And let's be honest, fossil fuels have been incredible for growing the global economy, for improving our quality of life. They've been the foundation for the modern economy, and really important. But that doesn't mean that we just have to stick to an old technology just because of all the benefits they've provided in the past. Innovation in technology is the key to figuring out this problem. Wind, here in Texas, growing still. Solar all over the world, it's gotten super cheap. Now, low penetration, there are still huge technical challenges with managing large amounts of wind and solar. But those are technical challenges that we are slowly beginning to solve. Ireland is 40% wind. Spain is 40% wind and solar. There's interesting new technologies coming online all the time. And this just shows overall global spending on energy technology. For the last 3 years, clean energy technology has dwarfed the scale of fossil investment. Over $1.6 trillion this year. So I'm optimistic that we can actually change this problem. I actually think we need to try. And so, for example, EVs are coming on strong, projected to be more than a quarter of the sales in this country in just a few years. Our companies have already made those investments. So when we come to the final question, climate science compels us to make large and rapid reductions in greenhouse gas emissions. I would say the risks that we're undergoing because of climate change, we can't avoid the problem. And reducing emissions is not the only thing we need to do. We need to prepare ourselves for the damages. We need to protect ourselves. And we need to think hard about climate equity around the world. But ultimately, we need to embrace technological innovation that can actually lower emissions and actually keep the worst consequences of climate change from happening. Thanks very much.
Well, the proposition sounds great. Why not reduce emissions? But large and rapid means, at least according to the UN, that currently rising global emissions would have to vanish within the next 3 decades to avoid allegedly dangerous climate change. Nevertheless, some say we've got to follow the science. But the real world has to balance scientific certainties and uncertainties against the growing demand for reliable and affordable energy. In that light, the proposition fails dramatically. Large and rapid reductions are unjustified, they're immoral, and they're fantastical. Let me begin with the word compels, which makes the proposition unjustified. The UN estimates we'll see as much warming in the next 100 years as we've seen already since 1900, about 1.3 degrees. During, or perhaps despite, that prior warming, we've seen the greatest improvement ever in the human condition. Lifespan, literacy, nutrition, and economic activity all increased dramatically even as the global population quintupled, and the rate of extreme poverty plummeted from 70% to 10%. Significantly, today's death rate from extreme weather is 1/50th of what it was in 1900. So for me, it beggars belief that a comparable warming over the next century would significantly derail that progress. Even though the climate varies a lot on its own, many people allege that we've broken the climate already in the past few decades. But the IPCC, in its latest report, says they can't find long-term global trends in most types of extreme weather events, including storms, droughts, and floods. So economic loss rates have actually declined over the past 30 years as a fraction of GDP, averaging about 0.2%. A wealthier world is a more resilient world. Now, maybe the future is going to be a lot worse, but the IPCC projects substantial economic growth even for emissions-heavy scenarios. In 2014, they said for most economic sectors, the impact of climate change will be small relative to the impacts of other drivers. And the Biden administration actually agrees with that, even as they talk about a climate crisis. This compilation of research results that the White House produced in the spring shows that only a 1% impact on the U.S. economy under a future warming of another 1.3 degrees Celsius. And there are similar results for the global economy. Of course, there are uncertainties in these projections. GDP is not the only measure of well-being, and the rich will fare better than the poor. But the term existential threat is hardly justified. Nevertheless, one might still fret about severe but unlikely climate impacts. And so we hear something very bad might happen. We don't know what or when or just how bad, but we'd better act. The well-to-do, we in the developed world, might clutch our pearls over that. But it's hardly compelling for most of the world, which has many more serious, immediate, and soluble problems. In other words, the proposition is a luxury belief. And the word us makes it immoral. The 1.5 billion of us in the developed world enjoy abundant and affordable energy. But the globe's other 6.5 billion people are energy poor. The inequalities are astounding. We Americans consume 30 times as much energy per year as the people in Nigeria. And 3 billion of the world's 8 billion people use less electricity every year than the average US refrigerator. Energy poverty means cooking with wood and dung. Smoke in the kitchen kills more than 2 million people every year. And while dining by candlelight is romantic, studying by candlelight is not. Global energy demand will increase 50% by mid-century as most of the world develops. Fossil fuels are the most reliable and convenient way for developing nations to get their energy, as they have long been for the rest of the world. And so global emissions are going to grow in the coming decades, even as the developed world's emissions decline. And remember, just to stabilize human influences, not reduce them, we've got to drive emissions to zero in the next 3 decades. Reliable and affordable energy is the overwhelming priority for developing nations. And so when the proposition says science compels us, the response from the developing world is, what do you mean us? The Indian Prime Minister, Mr. Modi, protests that the path for development is being closed to developing nations. And even the UK, which aspires to lead the world in climate change, whatever that means, is realizing that rapid decarbonization is going to impose an unacceptable burden on their poor folks. It is immoral for the developed world to deny the developing nations or even the poor in their own countries the energy that they need. And it's the height of carbon colonialism to restrain development by mandating costly and ineffective energy systems if we in the developed world are not going to pay the difference. And we're not, I can tell you. The proposition is also immoral because continued exaggerations like science compels induces eco-anxiety. Some 60% of young people globally are very worried about climate change, and many are reluctant to have children. Net zero by even 2100 would be an heroic achievement, but the world isn't facing climate catastrophe. And so it's pernicious to exaggerate the importance and urgency of reducing emissions at the expense of more immediate and impactful societal needs. Finally, the fantasy of large and rapid reductions. As the world is rushing off to try to rapidly reduce emissions, it's realizing, like Wile E. Coyote, that there are some fundamental issues that spell a very bad outcome. Let me list some of them for you. Energy is a critical societal system. It touches everything, everywhere, all the time, and it takes decades to change. Attempts to accelerate an energy transition will be, in fact, are proving extraordinarily disruptive. Zero-emission energy services will be more costly, and if wind and solar dominate, reliability will suffer. There will be shifts in domestic employment. Witness the current automobile strike in the US, which is due in part to the reduced labor needed to manufacture EVs. And there will be shifts in the flows of funds. Road taxes, which come from gasoline sales, will disappear, and vehicle financing is going to shift as well. Since energy is an important part of manufacturing, domestic manufacturing costs will increase in those countries that are reducing emissions, causing industry to move abroad, as we've already seen in Germany. The alternative energy technologies also require large amounts of expensive materials like copper, cobalt, and rare earths. New supply chains will have to be created, and there's going to be an awful lot of mining, whether here in the US or in friendly countries abroad. And maybe most importantly is the opportunity cost. Decarbonizing the US in the next 30 years is estimated to cost between 5 and 7% of the nation's GDP each year. That's a mobilization on the scale of World War II, and it won't be for 3 years, but it's for 3 decades. Is that the investment we want to make for uncertain benefits, but certain drawbacks, given that the nation and the world have many more concrete, immediate, and soluble problems? To sum up, the proposition is unjustified. There is no imminent climate catastrophe, so we need not make large and rapid reductions in emissions. The proposition is also immoral. We cannot condemn most of humanity to more expensive, inadequate energy, and so we shouldn't do it. And finally, the proposition is fantastical. Techno-economic realities mean that large and rapid changes are going to be expensive, disruptive, and counterproductive, so we can't do it. These 3 points, unjustified, immoral, and fantastical, warrant a sound rejection of the proposal. But as you reject large and rapid reductions, I suspect you're wondering, what does Koonin think we should do? I'll cover that in my closing remarks. Thank you.
Dan, if you'd like to offer your rebuttal.
Thank you. So I only have 4 minutes, so I'm going to make just 2 or 3 points. Steve, and we call each other Steve and Dan because we were friends long ago. Steve claims that what we're setting out to do by decarbonizing our energy system is immoral, because it would be unfair to ask poor countries to deprive them of access to fossil fuels, which he claims are the only way that they can have access to energy. I partly agree with him in that. If we were actually telling countries that they could not use fossil fuels, I find that incredibly unethical for the US, who's responsible for 25% of cumulative emissions, for example, to tell all of sub-Saharan Africa that they can't use fossil fuels, when cumulatively sub-Saharan Africa, except for South Africa, has put less than 1% of cumulative emissions into the atmosphere. But that's not what we're saying. We're not talking about depriving poor countries of access to energy, just the opposite. In fact, President Modi of India is a perfect example, who's absolutely embraced a solar revolution in India. He just doesn't want to be constrained from potentially using coal if they need to. But as a leader, he sees a huge opportunity in India for building out solar because it's gotten so cheap. And he's been outspoken on that. And in fact, my colleague Ricardo Hausman, who's an economist at the Kennedy School, he and I have been working on something called green growth, which is the idea that actually the energy transition for poor countries represents the best opportunity for economic growth over the last 100 years. And that's because many of them are sunny and windy, and they have water and biomass. And if that's the basis for our future energy system, then this is an incredible opportunity for many countries in the global south to participate in a way that they couldn't in our hydrocarbon-dominated economy. Whether it's wind and solar, whether it's biomass and biofuels, or whether it's mining for cobalt or copper or nickel or lithium. There are incredible opportunities for poor countries, and they don't want to do this. They don't want to go down this road that we've gone down. I will say one more thing about the timescale, because I think it's really important to think about the timescale of climate change and the risks we face. We're not driving a sports car on the Earth. The Earth is more like a supertanker, a giant supertanker that you can't just turn on a dime. We are unleashing changes in the climate system that have timescales of centuries to millennia. Steve says, there's no catastrophe ahead, don't worry. Well, many scientists disagree with him. The question is, from a risk perspective, how should we think about it? And if Steve's wrong, oops, sorry, timescales of centuries, so there's not much you can do about it. I think we should have the ambition to change. By the way, I don't think we can actually decarbonize by 2050. I don't think that's a reasonable goal. But I do think we should try, because this is what I do know. Just about every goal we've set in the past, and World War II is a nice example, although it was 35% of our GDP, not 5 to 7%. But World War II is a nice example. President Roosevelt set extraordinary goals in World War II for building up arms, tanks, airplanes, ships. Nobody thought we could possibly achieve that, and yet we exceeded those goals. We found that technology and innovation are like wind in our sails. So the idea that we should just give up and say, let's just keep burning fossil fuels and not change, just seems insane. We see this problem. There's a chance that maybe it's not, maybe Steve's right, but a lot of scientists think that he's wrong and that we have serious risks. And the question is, do we really have the right to make these decisions for thousands of future generations if we really plunge the Earth into a serious crisis? Thanks.
Good. Well, Dan made a lot of points. Let me just make a few in response to some of the things he said. A lot of the concern about future problems rests on the models, and even the experts say the models are awful, not fit for purpose at the regional level. They can't even tell us the sign of precipitation changes at the regional level, at least according to the IPCC and Tim Palmer, who is one of the world's premier modelers. On Pakistan and the floods, which Dan mentioned, when that happened, you know, the Pakistani environmental minister gets up and says, this is the worst flood we've seen since 1961, and you owe us because you made it happen. So, scientist I am, and I expect Dan had the same reaction, you go back and ask what happened before 1961. And in fact, the monsoon last year was not particularly unusual. What made it so destructive were human actions, but not greenhouse gases. The mountains had been denuded of trees, and so there was a lot of runoff, and there were 60-some-odd million people living on floodplains, all right? So climate, at least, it was not unusual. On heat deaths, you mentioned how many people in India are dying. It turns out that globally, 9 times as many people die every year from extreme cold than from extreme heat. You can read it in the peer-reviewed literature. And so as the globe warms, there are fewer people dying from the cold. And yes, some further people dying from the heat, but the net is that there are more people alive or less people dying from extreme temperatures in a warmer globe than there were, let's say, 50 years ago. On energy investment, India's investing a lot. You know, the world invested about $4 trillion over a recent decade in alternative and renewable energies, and the fraction of the world's energy that comes from fossil fuels is still 80%. So a lot of investment, that's great, but still 80%. And in fact, India has record coal consumption this year. Do we tell other countries not to use fossil fuels? Well, heck yes, we do. The World Bank will not fund fossil fuel projects, whether it's to exploit oil deposits that have been discovered or to build coal-fired power plants. And you know what? When the West won't do it, China does. I think that's about all I have to say.
Okay, brilliant. Well, gentlemen, thank you very much for those remarks, and thank you to the audience for all the brilliant questions that are coming in here. One theme that is popping up quite a lot is the idea of nuclear energy. And we have a question here, if I can get this to work again. Well, it's locked. Anyway, I'll fix that in a second. What role should nuclear energy be playing in these debates? And why do we not see nuclear energy perhaps raised as a major solution from the part of the debate where, or the side that would suggest that more rapid reductions are needed? If you want to start us off.
Sure. I mean, I think there's a very simple reason why we don't see that at the center right now, which is that nuclear energy is very expensive. That's just the truth of it. In this country, if you are a utility that's trying to decide how to invest tens of billions of dollars, are you going to build a combination of wind and solar and natural gas plants? Or are you going to build one giant nuclear power plant that might cost 3 times as much as you had hoped and is at risk for all sorts of other regulations? The answer is pretty obvious. We're not building many nuclear power plants. Economically, it's not viable. That being said, I do believe that nuclear is likely to play a major role as renewable energy grows beyond the point where it's easy to manage. And whether that point is 40%, where Ireland and Spain are, and Germany, or whether it's 50%, I don't think we know yet. But certainly more than where we are in the US right now. I suspect we'll reach that by mid-century or so, and I think there may be a nuclear renaissance in this country. You're seeing the UK building nuclear because they are trying to decarbonize rapidly, but it's very expensive. So I think nuclear will play an important role. That being said, 30 years from now, there's a lot of technology and innovation to come. And so while it does look like nuclear has this central role, you know, we have to wait and let the market decide. I don't think we should be picking winners at this point.
So the electrical grid is central to anybody's decarbonization strategy, and the current fad is wind and solar. The problem is you can't build a grid with just wind and solar because of intermittency. There are long times when neither wind nor solar generate, and so you need some dispatchable system that you can count on when you go through those periods of Dunkelflaute, as they're called by the Germans. If you ask me right now what looks like the right backup system, it's probably nuclear, 100% reliable, 0 emissions. The alternatives would be gas with carbon capture or batteries. I don't think the batteries are going to get there. The scale is just too long. You need, the scale of storage you need is just too long. You sometimes need weeks at a time, and that's an awful lot of batteries. So I think for that reason, nuclear is going to be really important. Big nuclear, which involves putting down a lot of money at once, is a non-starter economically. But small modular reactors, and when I was in the Department of Energy, I helped get that program started. Reactors on the scale of 100 megawatts or so, build them by a standard design, deploy them multiples at a single site, have a good deal of promise, and there's a lot of startup action in that particular field. By the way, China is deploying nuclear at some ferocious rate, even as its fossil fuel consumption goes up.
And that actually leads to another theme that's coming up, is the idea of China in particular, but also India. What can be done, and how much should it enter into our thought process as to what those nations are doing, regardless of what we're doing? And one example that's sort of perhaps telling is that a smaller carbon-emitting, nation such as the United Kingdom, taking very aggressive steps in some regards. Is there a point to that if China's coal plant construction is massively offsetting anyway, or that China is slowing down its rate of, getting to peak emissions?
Yeah, I think first of all, China is doing a lot to transition its own energy economy. They are building more solar and wind than anyone else in the world, as well as manufacturing a lot of solar for the rest of the world.
But more coal plants as well.
Yes, coal-fired power plants, but so I work heavily on decarbonization in China with colleagues at Tsinghua University. You have to be careful because the situation on coal in China is very different than it is in the US or in the UK, where coal is essentially just for power. It's just for electricity. 95% of coal use in the US is electricity generation. In China, 50% of it is outside of electricity, or at least it was. And what's been really transitioning is the coal use in other sectors, in metals and cement manufacturing and fertilizer and a variety of other industries. So that is actually really important. China expects it will stabilize its coal use in just a few years. And that's probably going to happen, even though its coal use in electricity is going up. And one of the reasons is they don't have access to cheap natural gas like the US. And so we can use natural gas. We've essentially displaced coal with natural gas in the US. China doesn't have that option. And so, but they're actually going to stabilize and maybe decrease their coal use, even though coal use in the power sector is growing.
So it's emissions that matter, not whether you're burning coal or gas or oil. China has promised that its emissions will peak in 2030 and it will go net zero by 2070. We shall see, all right? They've made other promises in other dimensions that have not quite worked out very well. Hong Kong being maybe the most salient example. The issue of small countries. I put up a quote, maybe you couldn't see it, from Rishi's government, actually, his home minister, who said, we're not going to bankrupt Britain to save the planet, right? And so the UK is probably 1% of global emissions, and it hardly matters at all what they do. You know, the old British prominence in the world maybe says that, well, other countries will follow. But, you know, as people do, energy is what's important. And they'll do what they need to do to get that energy.
Here's another question. Do you both believe, or do either of you believe, that there are special places in wilderness environmentally that should be protected from industrialized impact of large-scale wind projects? Also, maybe let me spin that into a slightly different thing. How much should environmental protection balance against sort of drilling in places like Alaska? You know, that sort of economic trade-off question.
So I have a colleague who was an ag economist at Berkeley who once told me the only people who don't pollute are dead ones. And even that's not obvious. So, you know, pick your poison, all right? You want wind farms with infrasound, despoiling the landscape. You want mining of rare earths and copper. home, abroad, or do you want drilling? I mean, there is almost a conservation of pollution. Yes, the CO2 is different in the sense that it lives, a lifetime of about 70 years. You can fit the curve with, there's a long tail that goes out, I know, but e-folding time is 70 years.
But that tail's like 20% of the total, and it
Well,
lasts for tens of thousands of years.
Yeah, I know. Anyway, that's what I would say.
Yeah, I think conservation and biodiversity, protection and preservation of biodiversity is incredibly important. And guess what? All environmental issues don't always align. Conservation is going to, for example, I personally believe that jet fuel, for example, and a variety of other transportation needs is going to require massive use of biofuel if we're going to decarbonize. And that's going to put conservation directly in combat with climate. So I think we need to protect certain parts of the world. At the same time, I think we're going to have to use the land a lot. The wonderful thing about fossil fuels is it's integrating time. It's taking photosynthesis that's occurred over hundreds of millions of years and using it in just a few instants of geologic history in the last century or so. And if we're going to get off fossil fuels, it's going to require more intensive land use. And that's going to be difficult trade-offs. We're going to have to make those choices. It's time to have those conversations. I think these goals, these ambitious goals, whether it's by the UK or by China or by the US, think about what you would do if you were a political leader. You have a problem like this. You'd set a very ambitious goal, probably unachievable, but on the other hand, you don't really know what technology and innovation can do, and so you see what you can do. Go ahead.
So let me say a word about ambitious goals. Ambitious goals are fine, but if you, in pursuit of those goals, destroy existing systems which function very well before you've got the technology, if you pursue those goals at the expense of other societal needs, and if you pursue those goals by scaring the bejesus out of young people, because that's how you get them motivated, people think, then ambition is, let's say, overdone. President Xi in China says we will not transition the Chinese energy system until there are viable alternatives.
Sure.
That's very different than the attitude in this country or in Europe.
Any thoughts on various forms of geoengineering that could reverse climate change? Should we be investing in those, or is that?
So Steve and I've worked a lot on solar geoengineering, and Steve and I actually, about 10 years ago.
07.
Getting old, 16 years ago, we spent 10 days in Santa Barbara together working on solar geoengineering. So Steve and I both have thought about solar geoengineering. This is the technology that you could actually put particles in the stratosphere and cool the planet, compensating for the higher greenhouse gases. It doesn't work perfectly, but it works remarkably well, potentially. First of all, let's be clear, it doesn't reverse global warming. What it does is it takes away the sting, cools potentially instantly the climate. It's the best analogy I've heard is it's a little bit like morphine. If you were having surgery, major surgery, heart surgery, doing it without anesthesia would be unthinkable. So you like the morphine. But if you only do the morphine and you don't actually have the surgery, that's probably a really bad idea. Yeah, the pain will be gone, but it's really not. And that's the thing with solar geoengineering. You can perhaps protect the planet for a while. Governance is a huge challenge. Who gets to control the thermostat that controls the whole climate for the whole Earth? Boy, that's a mess.
So, downsides. Once you start it, you can't stop. All right? If you stop, the particles last about 2 years in the stratosphere. If you stop injecting them, they fall out and the temperature zooms back up. So that's a problem. Another problem is that while on average it'll cancel out some of the heat trapping effects of CO2, it doesn't do it perfectly. For example, at night, it doesn't, because it works by reflecting more sunlight. So there will be collateral effects on the climate. More rainfall here, less there, and the liability issues are crazy, all right? Not worth thinking about. So I think We should be doing research to know whether this is a tool that we have in our back pocket, but to be deployed only under extreme circumstances.
And so another theme here is the idea of actual costs. And so one question, how costly efficient are wind and solar without government subsidies? And as a sort of extension to that, how much money should the United States, how much money would it need to give to developing nations to decarbonize on a more rapid time? How much should it give, if anything?
So let me take the second question first. We don't actually give a lot of money to countries to decarbonize. I think I actually think it's unfortunate. There's very little appetite for foreign aid in general in the politics right now. Both the left and the right have become pretty America first, actually. Think about the Marshall Plan. Think about what happened after World War II, where we spent a lot of money to rebuild Europe, not because we thought we were going to get the investment back or they would become a market for our goods, but because we wanted to help Europe recover after an incredibly traumatic World War. And that was incredible leadership of the US. I actually think that our times call for that kind of leadership. I don't think we have that yet. The next best thing is to lead by investing in technologies like what's happened with solar and wind and EVs, which then brings the cost down. And then those technologies become disruptive. So I don't know whether it'll be in 5 years or 10 years or 15 years, but not that long from now, EVs will truly be disruptive. All over the world, EVs will be so much cheaper than internal combustion cars that everybody will be driving EVs. It's not going to happen I think in the next 5 years, but it's going to happen much quicker than you think. And the automobile companies around the world are already investing in this.
I think if we're going to be giving money to other countries, which we do, but not very much, as Dan says, we should be doing it to directly alleviate the problems that they have. And, paying them to deploy wind and solar, for example, is just not solving that problem.
What are the panel's thoughts on the role of carbon capture and sequestration in reducing emissions?
You can do it. It's more expensive than just venting the CO2. It probably works. There's some hit on energy production because you use some of the energy to do the capture. It's viable, but it may not be the best way to reduce emissions.
20 years ago, we thought carbon capture and storage was going to be a critical technology for decarbonization. And that changed for a few reasons. One was the cheap natural gas essentially started to kill coal in this country. But a second reason was that wind and solar got cheap. I think that carbon capture and storage may yet have an important role, but most likely the most important role is going to be in very difficult to decarbonize industrial processes. Cement, for example, glass, a variety of other things that require concentrated streams of CO2 already, fertilizer plants, things like that, where they may compete well. But we'll have to see, because there could be other technologies that could become disruptive.
I want to say a word about the cheapness of wind, which is changing rapidly. If you read the newspapers, you will know that New York State had ambitions to have deployed about 4 gigawatts of wind immediately, and then another 5 in total offshore wind. And within the last few months, the developers of those projects have gone back to the Public Service Commission, or whatever it's called in New York, and said, we can't do it unless we get a rate increase of order 50%. Why is that? Supply chain issues, but more importantly, interest rates have gone up. For technologies like wind and solar, most of the expense is capital expense. And so you borrow, and the interest rate is very important. And as interest rates have come up to their current level, wind is looking real expensive. Similar phenomena in the UK.
On that sort of note, another question here. GDP per capita versus energy usage per capita directly linked. should the Western world accept a lower standard of living? Is that necessary if we are moving on a dramatic path to decarbonize?
I don't think I ever hinted that it should or that it would. I personally, I mean, there are many people who advocate consuming less. I think that kind of behavioral change, and you can show that if we all stopped eating meat, and I'm an omnivore, if we all stopped eating meat, there's no question you would require less land, you could save more water, it's all true, but I don't think the world's likely to change its behavior that way.
Sorry.
No, just so I think that changing behavior by consumption directly is not the way. I do think that a variety of things are poorly priced, and I think that economics can change people's behavior. And I think we need to, the problem of climate change is a global collective action problem. It's a commons problem. And economists would say it's very simple. You need to just insert the price. And then the things that are carbon intensive become more expensive, and our behavior will change. We'll use less of them. And I think that's very reasonable.
Of course, the price has to be universal across all countries. Let me say a word about GDP per capita and energy. In the developed countries, North America, Europe, Japan, the energy use per capita is reasonably constant. And I think in the US, it's actually gone down a bit over the last many years, even as the GDP has gone up. The connection between energy and GDP is strongest for the developing countries, and particularly for the countries with GDPs per capita less than $10,000, which is half the globe, actually. There's a more or less universal trajectory of energy use as GDP grows. It turns out to be about 5 megajoules per dollar. And one of my research questions is, why is it 5 megajoules? Why isn't it 50 or a half? That's a very interesting question. If we can understand that, then perhaps we can modulate energy use as those countries develop.
Another theme here is the balancing of geopolitical interests. Obviously, at the moment, we see what's happening in Israel and Gaza. Crisis events can arise, concerns with the US and China over the South and East China Seas. But also the moral point of China's use of, at least, in the sense of Xinjiang, effective slave labor for its economic purposes, but also in Africa in terms of some of the extraction efforts that feed into electric vehicles. How much of a balancing act do we need to take for the human cost, even if we accept perhaps that there is an earth cost that is significant as well?
Those folks working, it's awful, okay? But we should realize that's why China is able to undercut the West in part. Labor, environmental rules, and to some extent government subsidies are what has made them the dominant processor of critical materials, the dominant manufacturer of solar panels, and so on. From a human point of view, it's awful that they're doing that. If we don't want to do it, though, it's going to mean that the cost will go up to some extent.
So I think we sometimes forget just how miserable it is to be among the billion poorest people in the world today. There's a lot of people in the world who live in incredible poverty, and it's very hard to deny them a right to economically develop. That being said, and there's the same people are also among the most vulnerable to the impacts of climate change. They're the ones who will be most affected, whether in Bangladesh or across sub-Saharan Africa, whether in Pacific Islands or other parts of the world. And they don't have air conditioning. 10% of homes in India has air conditioning, and that's a much higher percentage than, for example, in Pakistan. I think that the energy transition actually represents, as I said, this incredible economic opportunity for these people. And if you ask me, 100 years from now, will the billion poorest people in the world, on average, be better off or worse off than they are today? I will tell you that climate change will make them worse off for sure. But I think the energy transition has the opportunity to perhaps make them overall better off? I think we don't know the answer right now. And I think that's really important.
I would agree with Dan, but I would have struck the word transition and just say energy will make them better off, whatever it comes from.
Should the US use industrial policy, like the Inflation Reduction Act, to address climate change, or apply other instruments of policy such as carbon taxes and cap and trade? What's the thought?
Should they? Should is a loaded word. Should represents a sort of value judgment.
Right.
I will tell you, most economists would say no, they should not. They should use a technology-neutral market mechanism like a price on carbon tax or a cap and trade system, something equivalent where the external problem, the carbon emissions, are taxed, are valued, and that would be a much better thing to do. But the reality of the politics in this country is nobody has the stomach for that, and we voters don't want that. That's not what people want. And so as a result, what do? They give out subsidies for certain industries. That's the political opportunity. And it's true all over the world. It's true in Europe. It's true in China. It's a lot easier than actually using smart economic policy. It's unfortunate, but I think that's true.
So I'm going to decline to answer that one and make a broader point. This whole quadrant that we're talking about involves many different disciplines. We've got climate science, we've got energy technology, energy business, and we've got economics, policy. Nobody can be an expert in all of them. And one of the dangers we've got in this discussion is you see people getting outside of their lane. So you've got the climate folks weighing in on energy. As Dan and I were talking, most climate scientists know very little about energy. With humility, I think the two of us are maybe a handful of people in the country who are conversant with both. And then you get the policy. So I'm just a dumb scientist with a little bit of engineering knowledge, and so I'm not going to weigh in on policy.
Okay. Well, I hope it might sort of breach your previous comment there, but if we look at what's happening in the Middle East at the moment, the potential for a regional war, how much of a concern is there that some of the changes that we are making in terms of, or might want to make in terms of our energy posture, would leave us extremely vulnerable in a crisis scenario to very significant economic challenges, or other parts of the world to that, if oil supplies, for example, were cut off?
Well, we're already vulnerable, right? I mean, a couple of million barrels a day glitch in the oil supply sends the price through the roof, right?
And if that was multiplied?
Yeah.
So I think that you have to realize a lot of the rhetoric around oil security is nonsense, is an illusion, because oil is a market. For example, when Russia invaded Ukraine, oil prices spiked. We paid so much higher prices at the pump. Everybody knows that. China, by the way, we don't import oil, pretty much. We net zero, pretty much. We produce all the oil we consume. China is the biggest world importer of oil, and yet they were paying a discount during that time because they were buying embargoed Russian oil at half the price. So the irony is we were energy independent, and yet we were paying higher prices, and China, incredibly dependent on imported oil, and they were paying half price. So the fact is, some of what you hear isn't quite correct. Here's what I think. Transition to, for example, electrification of vehicles makes us less vulnerable to oil price spikes, not more. It actually is great for national security. And frankly, diminishing the power of Middle Eastern, small Middle Eastern countries that are very rich in hydrocarbons and have major challenges in terms of human rights, I think is a good thing in the long run. And it's a good thing for the US.
Of course, you know, you will shift the dependence to other commodities, whether it's cobalt or copper or lithium. The difference, though, is that those would have less, glitches in those supply chains would have less of an immediate effect because for building new hardware as opposed to operating existing hardware the way oil is. So Dan's right in that sense. Probably more security or less vulnerability with some of the new technologies. But as we said, there are other downsides to them.
Shouldn't the effects on the environment from wind and solar, and human health for that matter, be considered before we take some of these transitions?
So that's frankly Tom, I'm sorry, your great question, and thank you for doing this. But that's a ridiculous question.
Okay.
And I'll tell you why. Because particles in the air from burning fossil fuels, both fuel in trucks and coal plants, kill more people than all the impacts of all renewables by a huge margin. You know, this famous 6 cities study, which was done at the Harvard School of Public Health, looked at particles in the air from 6 cities in the US, small cities, and showed that the difference between a 2.5 micron particle count of 30, forget the units, versus 10, 30 versus 10 was equivalent to 3 years of life expectancy. And just to calibrate people, 3 years of life expectancy is like what you would get if you cured all forms of cancer. So air pollution is really, really bad for you. It kills people at huge numbers. And by the way, when President Obama looked at his Clean Power Plan and the EPA evaluated the cost-benefit analysis, 90% of the cost-benefit was from actually reducing conventional pollution. So the huge benefit of the energy transition is also getting rid of coal and getting rid of diesel fuel in trucks, because guess what? It's really, really bad for us. By the way, in the US, the most polluted city they looked at was 30 versus 10. In Delhi, it's like 500. Different scale.
So I think it depends. That's a very Western-centric perspective. It depends on where you are. The example of China, 1980 to, let's say, 30 years later, enormous increase in fossil fuel use and pollution in the cities. But the death rate went down significantly because that new energy provided all kinds of benefits to society. So it depends where you are on the Kuznets curve, which is the curve of pollution as a function of GDP. When you're a developing society, there's a lot of pollution, and then you get rich enough to start to care about it. So there are many energy transitions. There's not just one, and there will be different paces involved.
Because climate action is currently a polarizing subject in the US often, what do you believe needs to happen so that it becomes, the question here says no longer polarizing, but let's say less polarizing? And you know, I'm kind of struck by the very, you know, congenial discourse here in contrast to this concern, you know, around the country and the world. I mean, are there avenues to sort of expand the experience of this stage into the broader discourse?
I think, and we're starting to see it already, techno-economic realities are going to force that conversation. Whether it's wind, solar, EVs, if you ban internal combustion engines, people are going to get mad. And then there's going to be a serious conversation, I think, about costs and benefits, and maybe also the certainties and uncertainties in the science.
You know, I think there's an incredible opportunity, and a lot of it's focused on awareness of impacts. I've been studying climate change for a long time, for almost 30 years, and 20 years ago, I would give a talk to a public audience, and people would think of climate change as something that's going to happen to us 50 years from now and across the world in some place like Bangladesh. My sense is that that's not what people think anymore. That a lot of people have experienced, for example, farmers. If you talk to farmers in Iowa, they're actually concerned. They see changes happening and they're concerned about it. And I actually think the way to reach people is on something we haven't talked about tonight because it's not the focus of our debate, but the question of preparing for climate, or what some people might call adapting to climate. We have to prepare for what's coming, because no matter what we do, climate's going to keep changing. What we can do is keep it from changing to what I think will be a catastrophic level, but we can limit the damage if we act now. But either way, we have to prepare ourselves for what's coming. That means, unfortunately, in Texas, we have to get ready for some more hot summers.
All right, on that note, I think I'm going to remind everyone, if they could make sure to post their new response or their evolved response.
Can you wait till after our closing remarks?
Of course, but to be aware to do that at the end. Sorry, thank you, Dan, for your, but then I think we can go to the closing statements. And I think Steve, you can go first.
So I think I've got one slide in my closing, but we could actually do without it. So I hope I've made my case against the proposition. A dispassionate look at trends in demographics, development, and energy technology shows that global net zero by 2050 is a fantasy, and that's quite unlikely even by 2100. But also the consequences of missing that goal won't be catastrophic. That doesn't mean that the world or we in the US shouldn't do anything. So here's what I think we should do. First, we've got to sustain and improve climate science. Our knowledge is not what it should be. Paleoclimate studies tell us how the climate changed in the past. Current observations with improved coverage, precision, and continuity will continue to tell us what the climate system is doing today, and models give only a fuzzy sense of what the future is going to bring. There's a particular need for a greater statistical rigor in the analyses and more focused modeling efforts to reduce uncertainties. Second, we have to improve communications to the public. We need to use the current jargon. We need to cancel the climate crisis, even as we acknowledge that human influences on the climate are growing, and we should be working to reduce them. The public has to have an accurate view of both climate and energy that gets beyond slogans like, "We're on a highway to climate hell with our foot still on the accelerator," said the Secretary General of the UN. Scare tactics like that erode credibility. Third, we have to acknowledge that energy reliability and affordability take precedence over emissions reductions. Europe's energy troubles are self-inflicted. Fossil fuel investment and domestic production were abandoned in favor of unreliable import partners and unreliable wind and solar generation. And mandated efficiency measures like home heat pumps and EVs were much too strong. It's easy to see that all that would lead to trouble. We've likely seen peak green in Europe as the continent confronts techno-economic realities. Fourth, governments have to embark on thoughtful and graceful decarbonization programs that incorporate technology development, economics, regulation, behavior, and estimate costs, timescales, and actual impacts on the climate. An essential element is research, development, and demonstration of new emissions-light technologies that reduce what Bill Gates calls the green premium. Small fission reactors, grid storage and management, batteries, non-carbon chemical fuels, and carbon capture and storage would be on my list of the most promising areas today. But programs that go beyond RD&D to meaningful deployment should not be the scattershot mandates and incentives currently in vogue. Energy is delivered by complicated systems that are recalcitrant for fundamental reasons, and so they're best changed slowly, by orthodontia rather than tooth extraction. And precipitous climate action is far more disruptive than any possible impact of climate change. Fifth, developed countries have to acknowledge the inevitability, if not the desirability, of meeting the developing world's energy needs. Most of the world today is energy starved, and fossil fuels are the most convenient and reliable way for them to get that energy. Without costly backup systems, weather-dependent wind and solar generation can't provide appropriate energy for those folks. I have asked many advocates of rapid global decarbonization what they would do to meet the developing world's energy needs. And I've yet to hear an answer that respects technical, economic, demographic, and political realities. Finally, there's a need to have a greater focus on alternative strategies for dealing with a changing climate. As Dan just mentioned, adaptation is most important. Adaptation is autonomous. It's what humans do. It's effective, it's proportional, and it's local, and therefore achievable. If nothing else, governments should work to facilitate adaptation. And I was gratified this weekend to see an op-ed in the LA Times saying as much by two mainstream climate researchers. To close, I hope I've shown you that large and rapid reductions in emissions are an overkill. They risk far more damage to humanity than any conceivable near-term impact of climate change itself. But also that there's a sensible path forward that'll moderate human influences on the climate while responding to growing demand in a reliable and affordable way. Thank you.
So Steve has just given you a picture of a choice between poor countries that can develop with fossil fuels or will fail to develop economically with renewable energy or with clean energy. I think that's a false choice. Just because we, over the last 150 years of the Industrial Revolution, that our economic development was based on fossil fuels. Coal, mostly, more recently oil and gas, but it was originally coal. Does that mean that that's the only pathway for poor countries to develop? That's ridiculous. We developed with typewriters, too. Should we make them use typewriters and dial telephones? I mean, come on, we're living in the modern world. And we have to think about technology and innovation. My list includes nuclear power and carbon capture and storage too. Those are all opportunities for both the developed world and the developing world. But I think the real question is this question of what does large and rapid emission reductions really mean? You know, it's true. There are these incredibly ambitious goals that a variety of world leaders have set. I'm a little skeptical about whether we can meet them, but I understand that that's what politicians do. They set ambitious goals, and sometimes technology surprises us, and actually we can do better than we thought. The question really is, should we be doing more or should we be doing less? And I would say the scale of the climate change that we're seeing today is terrifying enough to me as somebody who studies it. We're putting things in motion that cannot be undone. And therefore, as an insurance mechanism, even if you think that Steve Koonin is probably right about climate, I don't think he is, but even if you agreed with him, you have to admit that there's a lot of climate scientists who are very concerned. And if you start to look at the evidence, you'll see the changes are shocking and can't be undone. And therefore, an insurance policy of putting a little bit more policy support behind energy technology and innovation to ultimately decarbonize more quickly, that ultimately will spread to the whole world, that to me is a prudent path through our energy future. Thanks very much.
Right, so just a reminder, if you have not done your second vote, please do that so that we can contrast with the front. And remember the resolution, climate science compels us to make large and rapid reductions in greenhouse gas emissions. So it'd be interesting to see. I'll give people a minute or two there to do that. And we can post up the final results when we're about ready. Everyone done? All right. Can we put that on the screen and see what's changed? Okay. Wow, not a major change.
55, 57, a little bit.
So apparently we do not need to make major changes.
Well,
Or at least-
Dan's won with a few more votes.
Statistically, probably insignificant.
Well, anyway, I believe, Haley, on my part, thank you all for your questions. I apologize. They kept coming through and the screen was sort of shuffling them up and down, so sometimes I lost some of them. But thank you for a lovely discussion with the panelists. And I believe Haley, and thank you to all of you, Haley is going to come and make some concluding remarks.
Well, even though we didn't see any major changes from the pre and post debate poll, I think one thing we did see was a clear example of civil discourse. So thank you. Let's give another round of applause to our debaters and our moderator. And thank you again to all of our generous sponsors here with us today, and again to the Adolph Course Foundation for supporting the Campus Liberty Tour nationwide. And thank you most of all to all of you for being a part of this debate. Thank you.
Great.
Good.
Thanks.
Great.
Thanks, Tom.
Appreciate it. Well done.